In Lesson 3-2, we're going to talk about identifying a linear function. Now, this notation may seem a little scary, but we refer to it as f of x. So this function notation, we think of the f as like the name of the function. It's how we refer to or identify which function we're talking about. X is the variable we're using in the function. Now, it's important to note that f of x does not mean f times x. Let's look at an example to make it a little less scary. They're going to give us a function here, and they said we're calling it g of x. That means x will be the variable we see in our equation, which basically looks like a line, and g is what we're referring to. So this g of x is the g equation, if you will, and over here on b, we would recall it the h function, the h of x. Both of them have x in their equations, just like it did in our last chapter where we were graphing a lot of lines. So when they want us to evaluate each function for x, normally we have x's in our equations. That's why we call it g of x. But now, instead of x, they want us to substitute in a 4. That means wherever we see the x, we will replace or substitute it with the value of 4. By doing so, we now follow the order of operations where we take negative 2 times 4 gives us negative 8, and subtracting 3 more gives us negative 11. We would say g of 4 equals negative 11. What does that actually mean? On a graph, if you were to plot this line or equation, you would have the coordinate 4, negative 11 as one of the points or solutions to the graph. So if we quickly try h of 4, that means replace 4 in wherever we see the x in our equation. That would give me 28 plus 15, and that would be our 43. That means if I were to graph this line, the coordinate 4, 43 would be a solution or a point on the line. Now that we know function notation, sometimes you'll be asked to create the equation. In the previous chapter, we knew that y equals mx plus b gave us our y-intercept, or our starting value, and our slope, or our growth and change here for m. So if we're asked to write a linear function using either data or our table of values, we can note that our x is going up by 1 every time we look at this first table. We're moving over a step, over 1 in the x direction. But our y values are growing by 6.5. That is, if I add 6.5 and 6.5, I get 13. If I add 13 plus 6.5 again, I get 19.5. It's a nice, steady growth. So if we're supposed to write an equation for it, in this case, we would say our starting value was a 1, and we were adding 6.5. We're going to focus here first on our adding 6.5x. Now remember, when we were doing our y-intercept, it's when our x value was 0. If you're on the y-axis, your x value should always be 0. So if I was looking at this table, I don't actually have my x value of 0. But I could easily get it by going back 6.5, which would actually get me back to 0. So for my equation, my rule would be y equals 6.5x plus 0, because that is my starting x is 0 value. If we look at table B, we note that it is going up by 1 for each of the x values. But let's check the growth. It is growing by 3 each time. So my equation will be y equals 3x, because I can see the growth between each x value running over 1 is a growth of 3. But I need my 0 x value to give me my y-intercept. If I go back 3, I would end up at a negative 2 here. So that would be my y-intercept. Just as you did in the previous chapter, if you find these functions or equations, you'll be asked to graph them. Recall that we start with our y-intercept here at 1, and our slope is 3. So I would rise 3, run 1. Rise 3, run 1. And I could connect these points to create that line.